Mr. Avinja. Welcome to YourPedia. Let's start your snap interview. Sorry, full mock interview for your NPCIl interview preparation in the branch of electrical engineering, right?
Yes, sir.
Okay, fine. So tell me, what are your favorite subjects, Avinj?
So my favorite subjects are electrical machines, power system, power electronics, and network theory.
Okay, 4. The first
Yes, sir.
favorite subject is electrical machines, right?
Yes, sir.
Hmm. So, what is eddy current loss?
So eddy current loss are the losses that occur in the core of the machine. Actually, this is due to the change in flux. Whenever the change in flux occurs in the core of the machine, an EMF is getting induced in the core, and due to this EMF, current starts flowing in the core. That is why the loss due to this current is called as eddy current loss.
Then how to reduce eddy current loss?
Sir, basically, eddy current loss is dependent on frequency and peak flux density. Yes, sir. So if we have to reduce eddy current loss, then we have, and it is dependent on thickness square. So if we make thin laminations, then eddy current loss can be reduced. So that the
What is the
closed path of the
relationship
current.
between lamination and eddy current loss, Avinj?
Sir, eddy current loss is when we derive the formula, we get pi square f square bm square t square by 6 rho.
Okay.
So
That is
t square is the
okay.
is the thickness. So we have to reduce the thickness, and if we give the lamination over it, then the induced EMF will not be EMF will not be induced. Hence, eddy current loss will not be there.
So you
So
are
basically,
explaining
the
through formula, through concept.
so of lamination. So through concept, it is ki when as EMF is induced, it requires a closed path to flow the current. So if we divide the
So the
core into
resistance offered, simple, Avinash, the resistance offered for the eddy current flow is increased.
increase
So
due to
current will
resistivity.
decrease. So I
Yes,
square is going to I decreases, I square is going to decrease further, right?
yes, sir. Yes, sir.
What is hysteresis loss?
So hysteresis loss also occurs in the core of the transformer. This loss is due to the what happens whenever the core is changing in a transformer. The dipole moment of the dipoles present in the core, they have to change its position after every half cycle. So, but this change in direction is opposed by the intermolecular force. So to overcome this force and to change the dipole after every cycle, we require energy which is lost. This is called as a hysteresis loss.
So in linear transformer, air core transformer, what about hysteresis and eddy current loss?
So in an air core transformer, the permeability will be very high. So
Permeability
the
is high in air core, or it
air
is
core, yes, sorry, very, very low. Permeability is very low. So this eddy current loss and as well as the hysteresis loss will be very more because the flux that will be
more.
required.
Hysteresis and eddy current loss are more. Avins, first of all, where is the core, man? It's a air core transformer. If there is no core at all, what about the core
Yes, sir.
loss?
So core loss is proportional to flux, and in air, the reluctance is very
Avins,
high.
लेकिन मेटेरियल तो होना चाहिए ना. मैग्नेटिक मटेरियल है कहाँ पहले?
Yes, sir. तो
ठीक है.
उसमें होगा ही नहीं.
Hysteresis and eddy
हाँ.
current loss are depending on frequency, V to F ratio. That's fine. But you
Yes, sir.
told thickness of lamination T square, T is 0. There is no lamination. First of all, core
No
itself is
lamination.
absent.
Yes, sir. In air core, there will be no eddy
Can
current
you
and
draw the
hysteresis.
BH curve of a linear core transformer?
Yes, sir.
Come on. Avins, I asked about linear core. You draw non-linear
Sir,
core.
For linear core, uh, like B is equals to mu h, then mu will be very low in linear core. Uh, so
Come on, man, it is a straight line. I mean, it's a
it
straight
will be a
line.
straight line. It
It
will
is
be a
not going
straight
to
line.
have any width. It is a straight line.
Yes, sir.
From that also, you can say that hysteresis loss is zero.
Yes, sir. Because no area will be there. Yes, sir.
Hmm. What is Lenz law? Can you explain Lenz law?
So Lenz law is that uh, the co- whenever EMF is induced, or whenever induction happens, then the induced EMF is in such a way that it opposes the cause of induction. This is called as Lenz law.
It causes it opposes the cause, or it is going to opposes the changes in the cause.
Opposes the change in the cause. Yes, sir.
Fine. So Lenz law is the outcome of which law? Lenz law is from which law?
So means
So we have physics laws, Newton's laws.
yes, sir.
So Lenz law
Le,
is
le,
related which of the law?
so Lenz law will be related to, I think, third law of motion, sir. Every action has an equal and opposite reaction.
Okay, fine. Fine. Tell me, Avinch, there is a three-phase induction motor.
Yes, sir.
I am giving three-phase supply to the rotor, not to the stator. It is a slipping
Three
induction.
phase up. Okay, sir.
Now tell me whether it works or not, if it rotates in which direction. So explain your analysis.
Uh, Sir, if three phase supply is given to the rotor of the induction machine, three phase induction machine, then what happens? Uh, and it is rotating, sir. Rotor is rotating. So what happens? A
No, no.
rotating
First of all,
rotor is not rotating.
rotating magnetic field is going to produce.
Yes, sir.
How it is
Rotate.
going to start the rotation, you start explaining from there.
Yes, a rotating magnetic field is being produced, and due to this rotating magnetic field, the armature and conductors that are present on the stator induces a current in themselves. And if
Okay.
the armature conductors are short circuited by some resistance, then current starts flowing in the armature conductors. So, due to this current, there is a law that ki, if any current carrying conductor is placed in the magnetic field, then torque is produced to it. But this torque is produced in the armature conductor which are present on the stator, but the stator cannot rotate, so it will oppose the cause of induction, that is the rotator rotating. So rotator will start rotating in opposite direction to the rotating magnetic field.
I want to change the direction of the rotor rotation, then what can be done?
So if we have to change the direction of the rotor rotation, then what three phase supply that we are giving,
Hmm.
we have to give negative sequence supply, sir.
We need to exchange the phases, any one of two phases.
Phases, yeah, yes, sir.
Change the phase sequence, that's all. We have only two phase
Phase,
sequences. Two phase sequences, ABC or ACB, right?
yes, sir.
Yes.
Yes, sir.
Hmm. Fine. See, induction motor draws very high magnetizing current compared to transformer. Why?
Sir, this is because of the air gap present in the induction motor. In transformer, there is almost full magnetic core, and in induction motor, as the as the flux has to communicate with the field flux and the stator flux, the flux faces a air gap. So, due to very high air gap, the magnetizing current in the induction machine is high, and due to less air gap in the transformer, it is less in the transformer.
Okay, fine. Can you explain how induction generator works?
Sir, induction generator works. Uh, Induction generator. Yes, sir. Induction in generator is a machine that takes a prime mover input, that is mechanical input, and gives. Uh, Sir, basically, I would first like to say that if we rotate the induction motor with a speed greater than synchronous machine, then it starts working as an induction generator.
Why? If we rotate at less than synchronous speed, but still we are rotating, we are giving some mechanical. Why that mechanical energy is not getting converted to electrical?
Sir,
Not from
because in
not from the formula. You try to explain from the concepts. Yeah, from
sir,
formula
because
we can use.
be- because for induction generator we require reactive power. So if an
Reactive
NR
power
is
we
less,
reactive power we can supply from capacitor bank.
sir, can you repeat your question again?
We are rotating the induction machine at less than synchronous speed, but still we
Yes,
are
sir.
giving some mechanical input. There is some reactive power due to which magnetic field is produced. Then why it is not generating power? Why it is not behaving like generator? Why it is required for us to just rotate it at more than synchronous speed is my question.
Yes, sir. If we rotate the induction machine at less than synchronous speed, then the power that is produced is positive, and the torque that is developed is also positive. So the developed torque or the electromagnetic torque supports the cause of induction. So it operates as a motor, as far as I can make out, sir.
We are giving mechanical input, man. How it can behave like motor? Motor means which has to give mechanical output on its own, right?
Yes, yes, sir. Means you're saying we are giving mechanical input and we are driving the rotor at less than synchronous speed.
Yes, we are
And
rotating it.
yes, sir. If we are giving mechanical input, then rotor is rotating. And if we are induction machine is a singly excited machine, so we give a supply to the stator. A rotating magnetic field is being developed, and we are rotating it with less than synchronous speed. Then the relative magnetic field, magnetic flux will be ns minus nr. So ns minus nr, uh, due to ns minus nr, a EMF will be induced in the rotor conductors. Sir, I cannot make out right now. So if
Okay.
we are getting the magnetic field at relative speed as ns minus nr, and if a rotor speed is less than ns minus nr, then this is a positive term.
Okay, fine, good.
Uh,
You got it. Fine. Okay. Let's move to the next subject. Power system, right?
yes, sir.
What is electrical corona?
So the voltage in transmission line, the voltage gradient at the uh, surface of the conductor is very high. If this voltage gradient or electric field at the surface of the conductor is more than the dielectric strength of the air, then air around the conductor ionizes, or dielectric breakdown takes place. Due to this, around the conductor, a bluish green light or a reddish glow is formed around the conductor, which produces a hissing sound. This effect is called as corona.
What is the reason for corona?
Sir, reason for corona is because uh, electric field becomes electric field is very high, and if this electric field is greater than the dielectric strength of the air, then the air around the conductor uh, break down. This Due to this, corona effect happens. And yes, sir. And means the voltage should be at least equal to the critical disruptive voltage.
Hmm. How to reduce corona?
Sir, corona can be reduced by wait, sir, 240 corona can be the main effect of corona was the electric field was very high. So if we increase the conductor size, so the electric field will be less, because electric field is equals to is inversely proportional to radius. So if we increase the radius of the conductors, then electric field, then the corona loss will be reduced. That means bundled conductors can be used to reduce corona. And uh, and more reasons can be, if frequency is reduced, then corona can be reduced. And the other reason is, if it is operated in good atmospheric conditions, then corona will be reduced. And the conductors that we are using, that should not have any edges. So these are the
Tell me
methods
what is
to.
the advantage of corona?
So the advantage of corona is that corona, what it basically does, it dissipates the energy. So whenever a surge will come into the transmission line, then the energy will be dissipated quickly, and it won't affect the equipments of the power system. So this is one of the good effects of corona.
Mm, fine. What is the purpose of CT in power system?
So CT is the current transformer. This is basically used for measuring purpose, and this is basically used for measuring as well as protection purpose. The purpose of CT is that uh, the current that we have to measure is very high current that flows in the transmission line, but such a high current cannot be given to the energy equipments. So we have to reduce the current. For that, CT is used.
Okay. Fine, Avinash, let me give you feedback. Your performance is okay, but in electrical machines, wherever you given wrong answers, I corrected you there itself. Questions will be too crossy. I mean, they will ask you to draw the linear transformer circuit. Okay, linear transformer. So air core transformer will be linear. If you are using any magnetic core that is going to have saturation, definitely that is going to be non-linear,
Yes,
right?
sir. Yes, sir.
Right. So be careful. Listen to the question carefully. Huh? So at that
Sir,
induction,
linear means ki one which does not have saturation.
yes, it is not having saturation.
Okay,
If you use air core, it is not having saturation, right?
okay, sir.
Means though there is no eddy current loss, there is no hysteresis loss. This kind of losses are not there. Hmm?
Okay, sir.
Right? And it draws very high magnetizing current because
Yes, sir.
as it is non-magnetic most of the times. So for the what is the flux formula MMF by reluctance? Its reluctance is very high, therefore it need
Very
more
high.
MMF to establish the same flux, right? Its no
Yes.
load power factor will be very, very low.
Is
Why? Because it is
very,
drawing
very
no
low.
load current. So that way you have to link with the one another, right?
Yes, sir.
Over to
Okay. Network
Yes,
theory
sir.
is also your favorite subject, right?
Yes, sir.
Okay. Can you draw a low pass filter with passive element?
Yes, sir. Low pass filter can be done with a passive element.
Draw the circuit of that one.
Yes, sir. Yes, sir. One second.
Okay, it's
So
a
is it?
R in series and C in parallel, right?
Yes, sir. For RC circuit and for RL circuit.
Okay, understood, understood. Okay.
Yes, sir.
Can you draw what is the time constant of this circuit?
So for RC circuit, the time constant is R into C, and for RL circuit, the time constant is L into R. L by R, sorry.
L by R by. Okay. Can you draw the Bode plot of this one? Low pass filter.
Uh, yes, sir. For Bode plot, I'll write the V naught versus V in transfer function. So that will become V naught versus V net is, I think, 1 by 1 plus SRC, but still I'll derive 1 by S. Yes, sir. The transfer function will become V naught by V in equals to 1 by 1 plus SRC, and Bode plot we try in time constant format. 1 by 1 plus 1 by 1 C, and the cutoff frequency will be 1 by RC, and initially it has no flow. So
There is only one plot in body plot. There is another plot.
But sir, we can also draw the this is magnitude plot. We can also draw the phase plot also.
Oh, it's phase plot
Should
also.
I draw sir phase plot?
Yes,
Okay.
yes.
So we'll replace S by j omega, and then we'll get the phase as um, tan inverse omega RC by 1. Then we'll get minus tan inverse omega RC at omega equals to 0. We are getting 0 at omega equals to 1 by RC, and we will get 1 by RC, then tan inverse 1 equally 45, that will be minus 45 degree. And for uh, for 90 degrees, we should have pi by 2 degrees. Omega, if omega tends to infinity, so it will be minus pi by 2. Yes, sir. Sir, somewhat this will be. So it is going from
Why it is changing at two places?
0 to minus. Yes, sir.
Why it is changing at two places?
Sir, it is the phase that we get. It is minus tan inverse omega RC. Uh, so at omega equals to 0, we are getting phase as 0, and for omega equals to 1 by RC, we are getting phase at minus 45, and for omega is very high value, we are getting as minus pi by 2. So we are getting three values. So it is changing at two places. Means it is changing at places.
Okay, inside this one, which parameter will decide its initial slope?
Sir, for the Bode plot, for the Bode phase plot,
Yes.
sir, Bode phase plot in its in an initial slope, Bode phase plot is phase on the y-axis and omega on the. Sir, the time constant will, I think, decide its initials. So I'm not very sure about it, sir. If yes, sir.
What is resonance?
So resonance is a condition in which the source frequency becomes equals to the natural frequency of the circuit. In this, the line current is in phase with the is in the phase one. The current is in phase with the voltage, and in this in a resonance circuit, at least two storage elements should be available, in which one element should store energy in the form of kinetic energy, and other element should store energy in the form of uh, potential energy.
If I put two elements which are storing the energy in the form of electric field, then there will be resonance exist or not?
So if both the elements are storing the energy in the form of electric field, then
Yes.
resonance will not be produced. Yes, sir.
Why?
Resonance will not be produced. So because there is no uh, there is no transfer of energy. Like if we see the basic definition, it is definition is the source frequency, or should be equals to the natural frequency of the circuit. So that cannot be achieved if only one element having storing energy in the form of uh, electrical energy is available. So on the source frequency cannot be equal to that. And moreover, the main reason I think so is that the transfer of energy does not takes place, and that is why oscillation will not take place. So if oscillation will not take place, there will not be any there will not be any what the oscillation, there will not be any omega term, so it will not oscillate, and hence resonance will not take place.
Okay, let us take you have series RLC circuit.
Yes, sir.
Can you draw the voltage across the capacitor versus frequency? Oh,
Voltage across the capacitor, sir.
yes, versus frequency.
Yes, sir.
At resonance, why it is maximum before the resonance frequency?
Sir, it is maximum because before the resonance frequency, if we see the RLC circuit and we are drawing a voltage term. So before the resonance circuit, the capacitive term dominates. The reason is that the capacitive reactance is 1 by 2 pi FC. So if F is less than F naught, then the capacitive term dominates, and that is why before the resonant frequency we are getting uh,
So at what frequency it will get the maximum value of voltage across the capacitor? At which frequency you are getting the maximum voltage across the capacitor?
uh, sir, at the frequency where at the half power frequency. No, sir. Sir, just a second. Sir, I will try this by proper voltage division method. So voltage across the capacitor will be 1 by SC divided by R plus SL plus 1 by SC. If I take the denominator of all, uh, rationalize it, then I will get as 1 plus
Okay, just
S
tell me how you can
square
do that.
LC. Sir, actually, what we will do, I'm finding out the transfer function, and we want maximum VC. So for maximum VC, we want minimum denominator. So in denominator term, we will try to make it minimum. In the omega term, imaginary term, we'll try to remove, so we can
What is
get.
the equation? What is the equation of the voltage across the capacitor?
So the voltage across capacitor, it will be 1 by SC if we go in S domain, 1 by SC divided by R plus SL plus 1 by SC. Now I will rationalize everything and bring everything in simple terms, no fraction. Then it will come as a VC equals to 1 by 1 plus S square LC plus SRC. That will come equals to
Oh,
1 minus omega 1 minus omega square LC plus j omega RC. So 1 minus omega square LC is the term we can uh, minimize to get the maximum voltage across capacitor.
okay. Okay, enough. Let's come to your feedback part. Yeah. Network, network part is very good, right? And the rest
Yes, sir.
feedback, this are already given to you. Just follow that one, right?
Yes, sir.
Okay. Okay, enough. Best of luck from our
Sir, one question, sir. You asked the phase plot where from it will start. So what will be the answer of that?
the starting value of the phase float will be decided by what?
Uh, so I said time constant or omega equals to zero. I'm not sure.
So basically, whenever you are drawing a phase or magnitude float, so phase float, your starting value will be decided by pole or zero, which is lying at the origin.
Yes, sir.
That's what I'm asking.
Means at omega equals to zero only means we'll check
Yes,
the
yes, yes.
phase. Yes.
Right.
Okay, sir. Thank you,
Okay.
sir.